Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge IGCSE Mathematics Paper 4, which is the extended paper for October/November 2023. This is the 4-3 variant. I'll be doing questions 6 to 11 in this paper. Let's start. Question number 6. F of x equals 5x minus 3. G of x equals 64 to the power x. H of x equals 2 by x plus 1, where x is not equal to a negative 1. Why it cannot be negative 1? Because when we substitute x equals negative 1, this will be 2 by 0, but this does not exist. We know we cannot divide anything by 0. So they have given x is not equal to negative 1. A. Find the value of 1, f of 2. F of 2 is just 5 times 2 minus 3 because we just substitute x equals 2 into f of x. So we get 7. Part 2, gf of 0.5. That is going to be g of f of 0.5, which is 5 times 0.5 minus 3. That's g of negative 0.5. And g of negative 0.5 is just 64 to the power of negative 0.5. In other words, negative half. And the same thing as 1 by root 64. That's just plus or minus 1 by 8. That's our answer. B. Find h inverse of x. Well, we know that h of x equal to 2 by x plus 1. That's the function h. Let's just substitute y is equal to 2 by x plus 1. So that means x plus 1 equals 2 by y. And x is going to be 2 by y minus 1. So h inverse of x is just going to be 2 by x minus 1 because we need a variable x, we don't need y. We need to make this in terms of x. The reason we use the y here is so we can have another variable and then we could just solve for x or make x the subject, which is what we did. And that's just h inverse of x, 2 by x minus 1. Part C. Find x when g of x equals 1 by 2 to the power of 5. So that means 64 to the power of x is equal to 1 by 2 to the power of 5. And 64 to the power of x is just 2 to the power of 6 to the power of x. And that's just 2 to the power of 6x. So that means 2 to the power of 6x times 2 to the power of 5 equals 1. And that's just 2 to the power of 6x plus 5. And 1 is just 2 to the power of 0. So now, if we do equating the exponents, 6x plus 5 is equal to 0, and x is minus 5 by 6. So that'll be our answer. Part D. Write as a single fraction in simplest form 1 by f of x minus h of x. This is going to be 1 by 5x minus 3 minus 2 by x plus 1. So you can cross multiply on both sides. So x plus 1 minus 2 times 5x minus 3 divided by the product of the denominators. 5x minus 3 times x plus 1. And this will simply be minus 9x plus 7 divided by this denominator, 5x minus 3 times x plus 1. So that will be our answer. Minus 9x plus 7 divided by 5x minus 3 times x plus 1. Now we can go to question 7. A. Complete the table of values for y equals 3 cosine of 2x. Values are given correct to one decimal place. Well, at x equals 45, 3 cosine of 2x is just going to be 3 times cosine of 90 because 2 times 45 is 90. Cosine of 90 is 0, so 3 times that is also 0. Now for x equals 60, 3 times cosine of 120, and using our calculator or using your knowledge of basic trigonometric identities, that's just negative 1.5. Sorry, not identities, it's just the basic trigonometric values for 30-degree intervals of any given trig function. Now for x equals 80, this one, we don't remember any of the trigonometric values for cosine 160. So, of course, we just do it in a calculator. So cosine 160 is that, and multiplied by 3 is negative 2.5. 0.819 and negative 2.8 is to one decimal place. So that's our answer. D. Draw the graph of y equals 3 cosine 2x for 0 to 90 values of x. So when x equals 0, y is 3, x is 10, y is 2.8, x is 20, y is 2.3, and so on. We can just plot all the values which we know and which we have found so far. And we have a smooth curve. And now we can just connect all of these dots using our pencil. Let me just adjust this graph a bit. And there we go, we have our answer. Part C. Use a graph to solve the equation 3 times cosine of 2x equals negative 2 for 0 to x to 90. Well, we have 3 times cosine of 2x, the graph, when this is equal to the y value. So we need to find the intersection of this graph with the line y is equal to minus 2. Only then we can substitute y equals minus 2 into this equation here, and we'll get this. So y equals minus 2, line drawn on the graph, which I will draw right now, right here. It's a horizontal line, and the only one value for x which fulfills this is around 67 degrees. That's our answer. D. By drawing a suitable straight line, solve the equation 120 cosine of 2x equals 80 minus x for 0 to x to 90 degrees. Well, we only have the graph of 3 cosine 2x is equal to y. So how do we find for 120 times cosine of 2x is equal to this as well, which we do not have the graph of? Of course, we just draw the graph. But first, we need to make sure that this equation has the function, the original function in it. So we can write 120 cosine of 2x divided by 40 is equal to 80 minus x by 40 by dividing by 40 on two sides. So that means 3 times cosine of 2x is equal to 2 minus x by 40. And now we have it in the form of y equals 3 times cosine 2x. So we can draw this line here. So let's take some suitable x values and plot the y values for them. Let's take 0, y is going to be 2. 20, y is going to be 1.5. 40, y is going to be 1. 60, y is going to be 0.5. 80, y is going to be 0. Now we can just plot our points. And once we're done with that, we can simply draw a straight line through it. Sorry, let me just adjust this real quick. There we go. Now we need to know the intersection between this graph and this graph. So this graph is y equals 3 cosine 2x. This graph is y equals 2 minus x by 40. And this graph is y equals negative 2. So the intersection is at x is approximately equal to 33. We only know the approximate value since we cannot see exactly what the value is. In reality, the value could be somewhere around 33 but not exactly 33. That'll be our answer. Now going to question 8. A. The diagram shows a shape made from a major sector AOB and triangles OBC and AOD. OB is 6 centimeters, which is the radius of this sector. Obtuse angle AOC is 135, angle BCO is 90 degrees. 1. Show that angle BOC is equal to 19.5 degrees to one decimal place. Oh yeah, I forgot to mention BC is 2 centimeters. So we can see a right angle triangle here, right angle, and we have two sides. So of course we can find the angle enclosed in the triangle. We can find all three angles, but here we only need to find BOC. So compared to this angle, This is the hypotenuse, and this will be the opposite to that angle. So we know sine of angle BOC is equal to the opposite by adjacent, 2 by 6. That's 1 by 3. So angle BOC is just the sine inverse of 1 by 3. And doing this on our calculator, 1 divided by 3 sine inverse 19.5 degrees to 1 decimal place. And this is what we needed to prove, so we proved it. You can see that it says show that angle BOC is 19.5. We already have the value, so it's easy to say if our working is correct or not. That's our answer. Part 2. Calculate the area of the major sector AOB. We know that angle BOC is 19.5 degrees. Therefore, we can now find the angle AOB, which is the reflex angle, the one greater than 180 degrees. So reflex angle AOB is just going to be 360 minus the angles around the point, which we know, to get 205.5 degrees. Of course, this to 1 decimal place. And now the area of the major sector is going to be equal to this angle, 205.5 by 360 times pi r squared, which is the area, and that's pi times 6 squared. This area is just the area of the full circle if we drew it out. And multiplying by this gives us the area of the sector. So doing this in our calculator, 205.5 divided by 360 to get this, times 36 times pi, 64.6 centimeters squared. That's our answer. Of course, the 3 significant figures. Going to question part 3. C is the midpoint of OD. Calculate AD. If C is the midpoint of OD, and we know we can find OC because of trigonometry or Pythagoras theorem with this right angle triangle there, we can find the length of OD. And OA is equal to 6 centimeters. Notice that that is also a radius of this sector, so it'll be the same thing as OB, and that's 6. So we know these two sides, and we know the angle enclosed by the two sides. We can find the third side of the triangle using the cosine rule. And that's how we're going to do the question. Now let's just carry out the calculations. So using Pythagoras theorem, a squared plus b squared is c squared. So 6 squared is equal to 2 squared plus OC squared. And therefore, OC is going to be the square root of 6 squared minus 2 squared, which is square root of 32. Let's just leave it like this for now. So now we have found OC, and since C is the midpoint of OD, we have that in the question, we can find OD. So OD is equal to 2 times OC, right? Since C is the midpoint, so it splits the line exactly in half. So if you want to find the line which is longer, OD, we have to just double the length over here, since it's the same on both sides of the point C. So that's just 2 times root 32 centimeters. And now, using cosine rule, a squared equals b squared plus c squared minus 2bc cosine a. And this capital A is the angle opposite the side A, which is this angle, and the side A is this. And side B and C are just these two. You can take any one of the two to be B, and the other one will be C. It does not really matter. So a squared is what we need to find. AD is equal to b squared, which is, let's say, 6 squared, plus c squared, which is 2 times root 32 squared, minus 2 times 6 times root 32, 2 root 32, times the cosine of the angle 135 degrees, which we know. So this AD squared is going to be equal to 36 plus 2 times root 32 whole squared, which is just 4 times 32, or 128. So plus 36, that's 164. And now subtracted by 24 root 32 times the cosine of 135. Now we can use our calculator to evaluate this. So 164 minus, so we can do 24 times root 32 to get this, and then times cosine of 135 to get exactly negative 96. So if we negate that, because there's a negative sign in front of this as well, and then plus 164, you'll get 260 as AD squared. So AD is just going to be the square root, which is, as given on the calculator, 16.1 centimeters to 3 significant figures once again. That's the answer. Now, going to part 4. Calculate the total area of the shape. Well, we know the area of this sector, 64.6. So we just need to find the area of the two triangles. We know what OC is. That's the square root of 32. And we know that BC is 2 centimeters. Since this is a right angle triangle, this is the base, this is the height, or you can take this as the base, this is the height. It's still the same. Half times base times height is going to be half times 2 times root 32. So the area of this is going to be root 32. The area of triangle OBC is just, I'm just going to write down the values. Half times 2 times root 32, which is root 32 centimeters squared. Now the area, I'm just writing as A of this sector, we already know is 64.6. So area of sector OAB is equal to 64.6 centimeters squared. Now we need to find one more area, as I said, this triangle over here. So we know this side length, which is 2 root 32, and we know this side length, 6 centimeters, and this angle is 135, which is enclosed by two sides. So the area of this triangle OAD is going to be half times the product of two sides times the sine of the angle enclosed by two sides. Half AB sine C, which is just half times 2 root 32 times 6 times the sine of 135. And doing this on our calculator, that's just the square root of 32 times 6 times 135 sine to get 24 centimeters squared. Now if we add all these up, 24 plus 64.6, and then plus the square root of 32 to get total area, I'll just write as TA is equal to 94.3 centimeters squared to 3 significant figures, as usual. So that'll be our answer, 94.3. Part B. A sector of a circle has radius 8 centimeters and area 160 centimeters squared. A mathematically similar sector has radius 20 centimeters. Calculate the area of the larger sector. We know that the ratio of the two areas of these sectors will be the square of the ratio between the two sides. So the ratio between the two sides, a is to 20 whole squared, is just 160 is to this area of the larger sector. Let's just call it x. Let this be x. So 64 is to 400, which we can simplify dividing by 16 on both sides, to 4 is to 25 is equal to 160 is to x. We can convert both of these to fractions, and now we can find x is equal to 160 times 25 by 4. And doing this correctly, we will get 1,000 centimeters squared. This will be our answer. Now going to question number 9. Question 9. A is the point 0, 2, B is the point 3, 3, and C is the point 4, 0. A. Determine if triangle ABC is scalene, isosceles, or equilateral. You must show all your working. So to find any of these, we need to find the length of the sides. So the length of side AB, which is often written as modulus of AB, with these two large lines, vertical lines on either side, is going to be equal to, using our formula, distance formula, x2 minus x1 the whole squared plus y2 minus y1 the whole squared, and we square root this complete thing. And we can just substitute values. So the x2 and x1 is 3 minus 0, y2 and y1 is just 3 minus 2. So this is 3 squared, which is 9. This is 1 squared, which is 1. 9 plus 1 is 10. So AB is root 10 units. Let's not simplify. This is easier if we don't. Now, what is the length BC? That's going to be, using our same distance formula, the square root of 0 minus 3 the whole squared plus 4 minus 3 the whole squared. And that's just going to be negative 3 squared, which is 9, plus 1 squared, which is 1. And we square root this, so it's square root 10 once again. Now, what about the modulus of CA? So that's going to be equal to the square root of 2 minus 0 the whole squared plus 0 minus 4 the whole squared. That's going to be the square root of 2 squared, which is 4, plus negative 4 squared, which is 16, square root of 20 units. Now, since two side lengths are equal, which are AB and BC, both are root 10, triangle ABC is isosceles. Since an isosceles triangle has two equal side lengths. Let's go to part B. 1. Find the equation of line AC. Give the answer in the form y equals mx plus c. We can find m, y2 minus y1 by x2 minus x1. And that's just going to be 0 minus 2 by 4 minus 0, and negative 1 by 2 is our gradient. Now we can substitute any of the points C or A onto this equation, y equals mx plus c. So I'll be substituting 4, 0. 0 is equal to 4 times negative half plus c. So therefore c is equal to 0 minus this value. So 0 minus of minus 2. And that is 0 plus 2, or 2. So therefore, y is equal to minus half x plus 2, which is our answer. If you wanted to check that, you can substitute the value of a as well. There's the x, there's the y. So therefore, minus half times 0 plus 2, which is 2. And the y value is indeed 2. So this is the correct equation. Part 2. Find the equation of the perpendicular bisector of AC. Give the answer in the form y equals mx plus c. We know the equation of line AC, so we can find the perpendicular bisector gradient. So I'll just write that as m naught is equal to negative 1 by the gradient of AC, or negative 1 by m. That's negative 1 by negative half, simply 2. So now, the perpendicular bisector passes through the midpoint of AC, right? Since it is a bisector of AC, it splits the line into two halves, and the midpoint is the point which splits the line into two halves. Therefore, we can find the midpoint. Let's just call that over here. Midpoint is capital M. Notice this is capital M, this is small m, there's a difference. So I'll just name midpoint as capital M. That's just going to be x1 plus x2 by 2, comma, y1 plus y2 by 2. And this is our formula. Now we can just substitute the values of a and c, which are 0, 2, 4, 0. So the midpoint is going to be 2, 1. Now we have a gradient and we have a point on the line. So we can substitute all of these into y equals mx plus c. So 1 is equal to 2 times 2 plus c. C is equal to 1 minus 2 times 2, that is 1 minus 4, negative 3. Therefore, we have the gradient, which is 2, and we have the y-intercept, negative 3. Y equals 2x minus 3 is our answer. Let's go to part 3. ABCD is a kite. The point D has coordinates w, 4w plus 1. Find the coordinates of D. I have the 3 line segments which form the triangle ABC. Which two are equal? It is these two, right? So if you want a kite, we need 2 more side lengths which are equal. So we need D to be a point such that AD and CD are equal. The easiest way to do this is just draw a rough sketch of the graph. I was drawing it down here. So we have 0, 2, 3, 3, and 4, 0. So we can see that these three, this is A, B, C, as we can see there. So these two lines have equal length. So from logical thought, we can say D will be something like this, right? D will be somewhere over here. It can also be somewhere over here. That also makes a kite, as long as these are not equal. That would make it a rhombus. Well, the one thing we need to know is that for a kite, the diagonals intersect at a right angle. Why is this so important? Because this AC is a line we found in part 1 of this question. Minus half x plus 2 is the y. And we also know that the perpendicular bisector of this line is a 90-degree angle to the line AC. Since it is perpendicular, of course, therefore the point D will lie on this perpendicular bisector line. That's because when we draw two diagonals, once again, they will not just meet at 90-degree angle, they both will have one of them as a line and one of them will be perpendicular bisector. In this case, this line is going to bisect this one. Why can't it be this line bisecting this one? Because first of all, we already found that AC is bisected, and second, we need the mirror line of the kite to be the perpendicular bisector of the other diagonal. This is the mirror line because these two side lengths are equal and these two will have to be equal wherever D is. So that's going to be the mirror line. D, we know, lies on perpendicular bisector of AC. One second, let me see if B lies on that. Notice that B is a point which will also lie on the perpendicular bisector, since of course it is a diagonal. So if you wanted to check this fact, you could just substitute B into that equation of the bisector, which is y equals 2x minus 3. B is 3, 3. So substitute that. 3 is equal to 2 times 3 minus 3. And that is correct. So therefore, D does lie on this perpendicular bisector. That is just a way how you could think of it, how you could confirm that D lies on this. So this point D has coordinates of w, 4w plus 1. This is our second hint given in the question, which is why now we can put both of them together and substitute these two values into that perpendicular bisector. So 4w plus 1 is equal to 2 times w minus 3. We just substitute this is equal to y and this is equal to x. Therefore, 2w is equal to minus 4 and w is minus 2. So therefore, this is the x coordinate and the y coordinate is going to be just substituting this value into 4w plus 1. 4 times negative 2 plus 1, negative 7. So the coordinate D is minus 2, minus 7. And if you look at this graphically, the coordinate D will be somewhere around here. And drawing these lines, they look almost the same length, right? If you drew it accurately, they would actually be the same length. But this time I didn't draw it the most accurate. This is just a sketch to help you understand. But This is the criteria for the kite. These two have to be equal, these two have to be equal. You could try using the distance formula which I described in the A part to find the length of AD and DC to really confirm if it's correct, but it's better not to waste time if you already don't have enough time to complete the rest questions in a paper. So complete every other question first and then come back to this if you have a doubt and just check the distances. And then if you did check these distances, you'd find both of them are the square root of 85, which are equal, right? These two will be equal in that case. And therefore this is indeed a kite, and therefore the value of D is correct. Therefore we have our answer. We can go to question 10. A. Expand and simplify. 4 times 2x minus 1 minus 6 times 3 minus x. We can just expand the brackets by multiplying it like this. So 4 times 2x is 8x, minus 1 times 4 is minus 4, and then negative 6 times 3, which is negative 18, and negative 6 times negative x, which is positive 6x. 14x minus 22 is the final answer. Part B. Factorize completely. 6x squared y plus 9xy. Well, we can factorize an x and a y from this because they both have x and y. And 6 and 9 are both divisible by 3. That's the HCF, highest common factor. Therefore, we can take that out as well. 3xy times 2x plus 3. And this will be our answer. Now going to part 2. 4x squared minus y squared plus 8x plus 4y. We can see that the first part of this expression is in the form of a squared minus b squared. And this a is equal to 2x and b is equal to y. We can see that this forms this part of the expression. And this is just going to be a plus b times a minus b. And that's just going to be 2x plus y times 2x minus y. And of course, we have to add the second part, 8x plus 4y. That is going to be 4 times 2x plus y if you factorize it completely. Now we can see that there is a 2x plus y in both of these. Therefore, we can take that and keep this outside as factorization and then leave everything else inside. So taking this out and taking this out, we multiply this by whatever is remaining, 2x minus y plus 4. We don't really need these brackets here, and this is our answer. 2x plus y times 2x minus y plus 4. Now going to part C. Antonio travels 100 kilometers at an average speed of x kilometers per hour. He then travels a further 150 kilometers at an average speed of x plus 10 kilometers per hour. The time taken for the whole journey is 4 hours 20 minutes. 1. Show that 13x squared minus 620x minus 3000 is equal to 0. Well, how do you find the total time taken? If you do the distance divided by the speed, that's the time. So the distance divided by speed is just going to be 100 divided by x. And this is for the first part of the journey. First 100 kilometers. And of course, this is the timing for the first 100 kilometers. And 150 by its speed x plus 10, because he travels this 150 kilometers at x plus 10 kilometers per hour. This is the last 150 kilometers. Of course, there's the timing. And the total time taken is 4 hours 20 minutes, which is 4 times 1 by 3, or that's just 13 by 3 hours in improper fraction. So you have to add these two, 100 by x plus 150 by x plus 10 is equal to 13 by 3. Now 100 by x plus 150 by x plus 10 is just 100 times x plus 10 plus 150x divided by x times x plus 10 is equal to 13 by 3. Now that means x times x plus 10 is just x squared plus 10x. So we can do 13 times x squared plus 10x, because we bring this over to this side, multiplying, is going to be equal to 3 times all of this, because we bring this here and multiply by this. This will be 100x plus 150x plus 1000. So 3 times 250x plus 1000, and that's equal to this. So 13x squared plus 130x minus 750x minus 3000 is equal to 0. And 13x squared minus 620x minus 3000 is equal to 0. And this is what we want. This is what we have proven. That will be our final answer. Now going to part 2. Solve 13x squared minus 620x minus 3000 equals 0 to find the speed Antonio travels for the first 100 kilometers of the journey. You must show all your working and give your answer to 1 decimal place. Well, if the question asked for 1 decimal place as related to solving a quadratic, we know that we either have to complete the square or use the quadratic formula. Here, it's best to use quadratic formula. So x is equal to minus b plus or minus root of b squared minus 4ac by 2a. And we can just substitute the values. 620 plus or minus root of negative 620 the whole squared minus 4 times 13 times minus 3000. And dividing by 2 times 13 or 26. Now we can evaluate the square root using a calculator. Here we go. 620 squared is the same thing as negative 620 squared, but as you can see, it's still positive. And then minus and minus over here will cancel out when you multiply, so plus 4 times 13 times 3000. You get this, 540k, 540,000, 400. So let's just write this, 620 plus or minus root of 540,400 by 26. So let's actually do this now. We square root this, we get some 735.119 dot dot dot. And let's find the value if this is a plus. So if it's a plus, that means you will get 735.119 plus 620 divided by 26 to get 52.1 kilometers per hour. Of course, there's still 1 decimal place. And we have one more value. I'll just write here, where it is minus the square root of 540,400. So 540,400 square root, and we can make it negative and then add 620 to get this. Divide by 26, we get negative 4.42 or negative 4.4 kilometers per hour to 1 decimal place. Well, we know that speed has to be positive. Therefore, the speed Antonio travels for the first 100 kilometers is just x, and that is the positive value, 52.1 kilometers per hour. This value is rejected because it is negative. So 52.1 is our answer to 1 decimal place. Let's go to question 11. The diagram shows a sketch of y equals 18 plus 5x minus 2x squared. A. Find the coordinates of the points A, B, and C. The easiest thing to find is the y-intercept, which is B, since this point B is the point where x equals 0. So that means 18 plus 5 times 0 minus 2 times 0 squared. That's just 18. And this is the y value. So that means B is just x equals 0, y equals 18. we already found our y-intercept. Now the x-intercept is where y is equal to 0. This is where we need to do more working. So 18 plus 5x minus 2x squared is equal to 0. Now we can simply negate this. 2x squared minus 5x minus 18, and it's still going to be equal to 0, since negative of 0 is just 0. It doesn't really change anything. Therefore, we can now factorize this. And then if you factorize this correctly, you'll get 2x minus 9 times x plus 2 is equal to 0. And therefore, x is equal to 9 by 2, or x is equal to negative 2. So this is when y is equal to 0. So therefore, the point A, which is on the left of the x-axis, has the x value negative. That's just minus 2 comma 0. And the point C is just going to be the other point, which is on the y of the x-axis, 9 by 2 comma 0. So we have our other 2 points. That's our answer. B. Differentiate this expression. So differentiating it, we just differentiate this, and then differentiate this, and just add them all up. So differentiating 18, dy by dx of 18 is just 0. Since 18 is just a constant, it does not have any x value in it, or in other words, it's 18x to the power of 0. So if we bring down the power, 0 times 18x to the power of minus 1 is the derivative, and this is just going to be 0, since we have a 0 multiplied by anything is just 0. Now the derivative of 5x, dy by dx of 5x is just going to be, when we have 5x to the power of 1, we bring down the power, 1 times 5x to the power of 1 minus 1. This becomes 0. So x to the power of 0 is just 1. So this cancels out, this cancels, we have 5 left. So it's just 5 plus the derivative of this. So we have negative 2x squared. Bring the exponent down, 2 times negative 2 x to the power of 2 minus 1. This becomes 1. So you can cancel this out. It's just 2 times negative 2x, which is negative 4x. 5 minus 4x is our derivative. Part C. Find the coordinates of the point on y equals 18 plus 5x minus 2x squared, where the gradient is 17. We found the derivative in the previous question. Dy by dx is equal to 5 minus 4x. And in this question, the gradient is 17. So dy by dx is 17. So that means negative 4x is equal to 12. And x is equal to 12 divided by negative 4, which is minus 3. Now we can substitute this x value into our original equation to get the y value. So y is equal to 18 plus 5 times minus 3 minus 2 times minus 3 squared. That's going to be 18 minus 15 minus 18, negative 15. So the point is minus 3 comma minus 15, and that's our answer. With this, we have come to the end of the paper. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. I'll see you in my next videos. Thank you.